Hey guys, in this video, we're going to do a practice quiz together, and it's dealing with rational expression operations. Like number one, you're just going to simplify this rational, and two, three, four, and five, you're either going to add, subtract, multiply, or divide rational expressions. Okay, so let's go ahead and begin. Number one, remember, when you see the word simplify, you're trying to cancel forms of one that exist both on top and bottom as far as the same binomial or the same factor. So that's the first step that we're going to do always with these rational expressions is we're going to factor. So let's factor the top. So 2x and x will multiply to get 2x squared. Okay. And again, you could do this by quadratic formula or factor by grouping. I like to still do it the kind of trial and error, guess and check, but it's dealing with number sense method. And then 15 is what two numbers will multiply here to get 15. This is where this guess and check kind of occurs. So it's either going to be 15 and 1, or 1 and 15. It'll be 5 and 3, or 3 and 5. Okay, so in this case, we're going to go with, let's say we put 5 here, and we put 3 here. Okay, the reason why this works is because in the middle, I have a 5x, because I multiply, and on the outside, I have a 6x. And remember, we are adding these forms of some kind. So I can add these to get an 11, or I can add these to get a 1, like 6 plus a negative 5, if you will, to get a positive 1. Okay, so again, 6 and 5 are the numbers that are created. And when I add, I can get an 11 or a negative 11. And if I subtract, I could get a 1 or a negative 1. Well, a negative 1 is what I want because that's right here. So all I have to do is choose wisely of which one gets the positive and which one gets the negative. Okay, so the bigger piece is going to get the negative, obviously. So that's going to be this 6 right here. So we're going to put a negative here because then I'll have a negative 6. And then we're going to leave the 5 as a positive because when I add those together, I get this negative 1, which is what I need for my B term. Okay, so let's go ahead and put this positive here. And now it does check out as far as positive 5 and negative 3 still multiply to get negative 15. We get our B term of negative 1 and our A term coefficient, our A coefficient is still 2x squared. Okay, so that's how you factor that with number sense kind of trial by error or guess and checking. Now the bottom is just going to be a straight up GCF. What's the biggest factor that I can factor out from both pieces? Okay, because again, terms are separated with addition and subtraction sign. So I have a binomial on the bottom. So the biggest piece that I can factor out from both of them is going to be a 4. And I'm left with 2x plus 5. Now, you notice that there's a 2x plus 5 here and a 2x plus 5 here. Remember, it's not that the 2x cancels with the 2x and the 5 cancels with the 5. It's the entire piece cancels with the entire piece here. And the reason of that is because you have to cancel between multiplication pieces. There's a huge multiplication right here that we're going to kind of like chop this off. And there's a huge multiplication piece right here where we're chopping this off, otherwise simplifying, canceling to a form of 1 where x minus 3 over 4 is going to be our final answer. There aren't any other pieces that will simplify. So we have x minus 3 over 4. And that's it. That's going to be your answer for number 1. Let's go to number 2. So number 2 is not just simplifying. It's actually trying to add these fractions together. But the same first step exists as far as factoring all numerators and denominators. So let's go ahead and start by factoring. And the bottom left will factor to x plus 2, x plus 1. Again, that's because 1 and 2 are going to multiply to get that C term. X and X multiply to get that A term. And then this B term right here is going to come from 1 and 2x to get 3x. Again, remember, you multiply those pieces and then you add whatever they are to get that B term. Okay, so those are the factors of our bottom left portion. Now, here's where we ask ourselves, are these denominators common? Well, they almost are. This second fraction is missing an x plus 2. And I can't just multiply an x plus 2 in the denominator and call it quits and be like, okay, the denominators are common, we're good to go. I can only do that if I multiply by a form of 1. That's the legal move, mathematical move, if you will, that you can do to this x over x plus 1 rational expression. So now I have a common denominator, okay? So what we're going to do is we're going to combine this to be one huge fraction that has a common denominator of x plus 2, x plus 1. And you could do x plus 1, x plus 2. Order doesn't matter with multiplication, but nonetheless, they're still common. Now we have to work with our numerators. We want to add both of these numerators together. But before we do, let's go ahead and distribute this so that this little piece is going to be like an x squared plus 2x, okay? And we are adding all of this. That means if this was negative, we would distribute the negative on all the terms that come after this parentheses. Okay, so that's a really good habit to get into, especially going into pre-cal and calculus, is this parentheses is very, very important on a step like this. Okay, well, this is addition, so the signs aren't going to change, so it's just going to be exactly what you see. Okay, now we're going to carry this down and have x plus 2, and now I can combine my entire numerator together with like terms. We have an x and 2x, so we get 3x. And then we have a 2. So plus 3x plus 2. So we have like a standard quadratic form, if you will. Let me go ahead and move this over to the left. And we can factor this piece. We know that this factors out to x plus 2 and x plus 1. Okay, so we'll say x plus 2 and x plus 1. And look, we can cancel this entire piece. Again, here's multiplication. So the cancellation, that will cancel with this as a form of 1. And then this will cancel with this piece, this binomial, as a form of 1. So please do not think, ooh, they disappear, they go away, it's 0 left over. No, it's a form of 1, so my final answer is going to be 1. Let's go to number 3. So first step, let's factor out the pieces. I can factor out here a GCF, and I can do a difference of squares right here. So x plus 5, x minus 5. Okay, and this is multiplication. So I don't need common denominators. Again, I only need common denominators when it's adding or subtracting. Okay, so we're going to multiply with x plus 5 and 3x plus 1. Again, we are factoring to see, does something reduce? Can it cancel to a form of 1 like these ones did here and these did here and all these other places, okay? So let's go ahead and go to the top right. We have a GCF of 3, so that we inside parentheses, we have 3x plus 1, okay? And remember, multiplication glues this entire fraction, which is one term, with another term. And they become one huge term, if you will. Okay, so this is going to basically get together as one huge fraction that's quote unquote glued together with multiplication. One huge monomial. Okay, so let me go ahead and come over here. And I'm just going to write it as one huge fraction where multiplication exists right here. Between the x plus 5 and 3, between the 3 and 3x plus 1, and between these three binomials on the bottom, okay? So now that multiplication exists, now I can cancel forms of 1. This will cancel to a form of 1 with this binomial, x plus 5 and x plus 5, and all I'm left with that won't cancel is going to be 3 over x minus 5, okay? So this would be my simplified final expression. Now, remember, this is all one term where you can cancel the way I just did. You cannot cancel when there's more than one term. Over here we had 2 terms because they were separated by addition or subtraction. So understand when you can cancel and what operations exist in between the pieces, and then you can go ahead and simplify from there. Okay, so let's move on to 4 and 5. So we have a subtraction problem. So currently we do have 2 terms. We won't be able to combine this into one huge term the way we did this previous number 3 piece, as far as just rewriting it with that multiplication in between, because we need a common denominator. This over here, though, just comparing and contrasting these, is a division. It's a form of multiplication. We just have to do that keep, change, flip thing to where we rewrite it as far as a multiplication problem. So let me go ahead and set this up. So we're going to start with 4. We're going to have x plus 2 as a denominator over here, and then x minus 3, x plus 2, and then we have 10. Notice that the denominators aren't common yet. We need to multiply by a form of 1 of something on this first fraction that this one has that this one doesn't yet, okay? So we're going to put this x minus 3 over here to make them now common, but I have to do it as a form of 1. Now, a common mistake here is people will try to cancel this out. You're defeating the purpose, actually, of trying to get a common denominator. So you don't want to cancel that out. You want to keep that because now you have common denominators, which you can write this as one huge fraction that has a common denominator of x minus 3 and x plus 2. That's the difference between adding and subtracting versus multiplying and dividing these rational expressions. Now we're going to simplify this out by distributing this x so that we get x squared minus 3x. And then it's going to be subtracting all of this numerator. Well, that's just subtracting 10. You don't have to distribute because there's just one term. So we're going to put minus 10. So we're going to factor again. You always want to factor as far as trying to see what can reduce cancel. And we have x minus 5, and x plus 2. And on this common denominator that we had from before is x minus 3 and x plus 2. And you see, there's a form of 1 because right now, as it stands, only multiplication exists between these binomials. I can cancel the entire binomial right now. So my simplified leftover rational expression is going to be that right there. Okay, our last problem. We're dividing by a fraction, which is the same as multiplying by its reciprocal. So we're going to say x cubed y over 4xy to the 4th is going to be multiplied by the flip, ay squared over x. Now, again, this, like number 3, because this is all one term glued together with multiplication, different than number 4 and number 2 back here with these addition and subtraction pieces, I can write this as one huge fraction that's glued together. Okay, so let me go ahead and do that. Again, that's the difference between addition and multiplication and division and subtraction pieces going on right here in this unit. So we'll bring this together, and now it's glued together with multiplication. There's multiplication here, 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 and here. Okay, so on the bottom, if I combined all my x's together, I'd have x squared. And if I combine all my y's together up top, I'd have 8x cubed, y cubed. Okay, and now you can reduce. You see that there's 3 up top, 4 on the bottom. The bottom wins by 1. So we're going to have 1y left over on the bottom. Then you have x cubed and x squared. So the top wins by one of those x's. And then I can reduce 8 over 4 to 2 over 1. Okay, and I'm just going to keep that 1 not written so that its final answer is 2x over y. So again, please remember the steps as far as when do I need a common denominator? When can I cancel? And again, you are not canceling pieces at a time. You're canceling the entire the entire binomial factors, such as this, or the terms if they're single, like this. Like you notice that there aren't any parentheses over here. It wasn't like x cubed plus something in parentheses. So those are individual pieces that you can do, okay? So again, that's all the steps that are included in this practice quiz with simplifying rational operations. Hope it helps.